All right, so example 3. In example 3, we're told that the angles of elevation of the top, of the bottom and top of an aerial on top of a vertical tower from a spot 50 meters from the base of the tower are 50 degrees and 57 degrees respectively. All right, what about this thing? So there's a tower. When you hear the term aerial, it's sort of like another way of saying antenna. An aerial is like another way of saying antenna or a satellite or just an antenna. So let us try and draw a diagram. So there is a tower. This is my tower. Now, on top of this tower, there's what you call an aerial. This is my antenna. And the antenna is on top of my vertical tower. Now, from a spot 50 meters away, so here's my spot, and this spot is 50, sorry, not 15. This spot is 50 meters away from the base of this vertical tower. That's vertical. This is horizontal. The angle between vertical and horizontal is always 90 degrees. Now, from this spot, the person is looking at the what? Bottom of the aerial, and he's also looking up at the top of the aerial. The person at this spot is looking at the bottom and at the top of the aerial. So that would be his line of sight. All right. Let me try and see if I can get better lines. That's a little better. And that's a little better. That's my line of sight. All right. Now, angle of elevation, the angles of elevation of the bottom and the top are 50 and 57 degrees respectively. Remember, down here is the horizontal. Now, angle of elevation is the angle between the horizontal and the line of sight when you're looking up. So if you want to represent angle of elevation, you have to start from the horizontal, draw a curve until you get to the line of sight. This is 50 degrees. And that is the angle of elevation from the what? That is the angle of elevation of the base of the what? Aerial. That is the angle of elevation of the bottom of the aerial. The person is at the spot looking at the bottom of the aerial. The 50 degrees, which is the angle between the horizontal and the line of sight, that is the angle of elevation of the bottom of the aerial from the spot. Now, to represent the next one, I'm going to start at the horizontal and draw a curve until I come around to the line of sight. That angle here is 57 degrees. Angle of elevation is always between the horizontal and the line of sight. And the 57 degrees is the angle of elevation of the top of the aerial from the spot. All right, so that is the answer to A. What were we supposed to do? We're supposed to, in the space below, draw a clearly labeled diagram to illustrate information and include I, the 50 degrees and the 57 degrees angle, which we have done, the 50 meter length, which we have done, and any right angle, which we have also done. What I want you to do now is see if you can do the rest of the question without my assistance. All right, so let's go to the B part of the question. Now, in the B part of the question, we're asked to I calculate to 1 decimal place I, the height of the tower. All right, so this is the tower here. So the height of the tower, I'm going to call it X. That's the height of the tower. All right. Now, that side X is opposite, is in front of the 50 degrees, because the angle associated with the with X is the 50 degrees. All right, so X is opposite to the 50 degrees, and the 50 is adjacent. Now, the trig ratio that includes opposite and adjacent is tan. So I'm going to say tan is equal to opposite over adjacent. And of course, the more I write this, is the more I'm likely to remember it. And so the tangent of 50 degrees is equal to opposite X over the adjacent 50. Now, if I have one fraction is equal to one fraction, to get rid of the fraction, I must cross multiply. So 1 times X is X is equal to 50 times the tangent of 50. I'll put that in my calculator and press equal. And this is equal to 59.6 meters. And so the height of the tower is 59.6 meters. So that's this distance here. It's 59.6 meters. The next thing we're asked to do is we're asked to calculate the height of the aerial. Now, let me call that Z. Now, for starters, you do not have any way of finding Z directly. So you have got to have an indirect approach to find Z. To find Z, you have to first find this height here, I'm going to call Y. Now, Y is the height of the it's the height of the tower plus the height of the aerial. All right, so you'd have to bear in mind that there's a large right angle triangle, and that the angle for that triangle is 57 degrees. The angle for that triangle is 57 degrees. All right, you'd have to be able to see that. All right, so let's erase that. We don't want to have the thing too crowded. Now, Y is in front of the 57 degrees, so it's opposite. And the 50, the line of sight is the hypotenuse, so the 50 is the adjacent. The ratio that includes opposite and adjacent is tan. So I'm going to say the tangent of the 57 degrees is equal to opposite Y over adjacent 50. All right, I'm writing madness. So this is tan of 57 degrees. If I have one fraction is equal to one fraction, to get rid of the fraction, I would cross multiply. 1 times Y is Y is equal to 50 times the tangent of 57 degrees. And so Y, therefore Y is equal to, so you're going to put that in a calculator, 50 times the tangent of 57 degrees. And the answer is, this looks to me like it is 77.0 meters.
Wow.
All right, so this height here is 77. So the entire thing, which is the tower plus the aerial, is 77. The tower is only 59.6. So it means, therefore, that the height of the aerial, Z, Z is equal to 77 minus 59.6. And so the answer is, the answer is 17.4 meters. The height of the aerial is 17.4 meters.